if the mic's going to work, then I will begin my talk. The ladies asked me to dance, but instead I'm going to present a technical topic, and let me tell you, there's way too many people for such a fringe topic in the audience, because this is really an experiment. But first, let's talk a little bit about how I came to be here. Clicker doesn't work. I guess we'll go manually. So I work for A1 Digital. A1 Digital is a subsidiary of the Austrian Telecom, but some of you might know it from different countries as well. And also a majority shareholder of Exascale, which is a cloud provider. Now I try to specialize in explaining things to people, even if it's very complex, in very simple ways. And to do that, I often do research projects. I try to figure out how certain things work. And to be honest, when I come to a problem, for example, run across something, I get annoyed. And when I get annoyed, I try to fix it. And sometimes the fix ends up being worse than the original problem. Exascale has a couple of nodes, these 4 ones, and I'm being told that there's a 5th one opening up in Sofia. So if you're looking for an European cloud solution, then you might want to give it a look. I also have a little bit of swag, so if you ask interesting questions afterwards, I'm happy to bribe you with an Exascale bottle or a notebook. Now, in my free time, I also write a blog. So if you want to read more from my crazy project factory, then feel free to go to this web address. And yes, there's a Z in my name, which is quite confusing if you're coming from Poland, because there it's exactly the other way around. Okay. So for this talk, I marked the things that you might want to take home from this talk and apply to your everyday work. These are marked with a red finger, and we will collect them at the end. Now the question is, can you use Gentoo Linux as a Docker build system? And the answer is actually kind of. It works, but it's not necessarily production ready. So you might end up using it in the future, and I really hope that you do. Just how did I come to build this? If you know Gentoo Linux, it's not exactly small and simple. So what you think of a Docker container is like really tiny, 10 megabytes, 20 megabytes. There's a service running in it and nothing else. Now Gentoo Linux is massive. Gentoo Linux is a distribution built from source. That means that it will have all the source code, the compilation steps, the build tools, everything in there. So why did I end up doing this project? I tried this. I wanted to run a simple PHP application, so okay, let's take the stock PHP container and just run it and run my PHP application. This should have been a 5-minute process. However, when I tried this, GD, if you don't know it, is a quite popular image manipulation library for PHP. What do you think I got? This thing. Beautiful, isn't it? Yeah, basically what this says is the official Docker image for PHP does not contain GD. So how do you install GD? On Ubuntu, I would just apt-get install PHP something GD, right? Well, take it easy, because I was quite surprised why this is happening. I just went to Google, okay, how do I install GD in this thing? And then I found this helpful utility, which the official maintainer said, okay, this Docker phpx install is supposed to install some extension, which said, great, this is a wonderful feature. So I'm going to install GD. And yeah, no. I ended up going back to Google because, of course, it didn't work. And then I found this. This is how you're supposed to install GD. This is what happened. I was, what? Why? And if you look at this, this does a couple of things. First of all, it's based on a Debian system, so why at all? And second, everything that you need for GD, you have to collect manually. If you're not familiar with how you compile a software on Linux, then it's basically you have the source code, and then you have a bunch of libraries. For example, in this case, GD or some other library that depends on it is going to depend on libfree type 6 and libjpeg and libpng. And in contrast to what you would have expected, that you say, okay, install me the GD extension, what it did is like, yeah, you take care of it yourself. You go figure out what libraries this GD library needs. So it's your responsibility as a user. You just want a decent PHP Docker image. And what you end up having to do is figure out how the GD extension works and what libraries it needs. and so on and so forth, and then how to install the whole thing. So enter the Gentoo build system. The reason why I got furious about this, because this is a problem that we solved 10 years ago. There is no need, there is no reason why this would need to be, this would need to happen. And yet I see it a lot of times when somebody's building a custom PHP Docker image or a custom Nginx image with Lua modules and some other modules that are not available as a binary package. People just end up writing the compilation steps right in their Docker file. So they install G++, the compiler, the build utils and whatnot, and then compile everything from source. And then they end up having to put their Docker file full of stuff like, okay, install those 10 libraries and the header files and whatnot. So the Docker file gets really bloated. So what I wanted is a simple system to just say, okay, I want a PHP image or Nginx with these extensions. And the build system should take care of that. So if you do this in Gentoo Linux, you use the emerge build tool. So emerge is like the package manager of your average Debian, for example. Debian would be apt, and Gentoo it's emerge. You do -- ask, okay, tell me how you're going to build this. And Gentoo Linux gives you this very useful output. What it does, first of all, it says, okay, we have these dependencies that are going to be installed. And more importantly, there are so-called use flags. So the use flags influence how Gentoo will build the specific image. So in this case, for example, PHP has ACL, BurkDB, bzip2, and whatnot enabled. And for example, sockets disabled. If you wanted to enable sockets, then you would say you would enable a use flag plus sockets. And then Gentoo Linux would take care of compiling sockets in and installing all its dependencies and whatnot. And more importantly, if you did not want something, for example, you did not want simple XML in your PHP installation, then you would just do -simple XML. Simple as that. So it's supposed to just work. So this is how you set a use flag. You set an environment variable, or you can put it in a config file as well, and you just say use GD. I want GD in my PHP installation. And then you can see the output changes like this. In this case, it's going to compile libpng and ASM and libjpeg turbo, whatever that is, into my system. So I can just choose to say, okay, I want GD and pull in all the dependencies. And I can customize my Docker image or my Gentoo installation the way I want it. This is especially useful if you're a guy like me who does not like to have extra stuff there that you don't need. So by now, I guess you figured out I kind of love Gentoo. I don't use it as an everyday system because the compilation takes a long time and so on and so forth, so it's not really practical. But I love the build system. I love how they made it configurable and you can just customize the system to your heart's content while still having a proper package manager and being able to properly manage your system and not having to compile everything by hand. If you look at the package structure, how packages are built in Gentoo, you will find so-called ebuild files. These ebuild files are nothing but glorified shell scripts. And these shell scripts govern how the compilation process is done. And in this case, for example, the dependencies are handled like this. If the GD use flag is enabled, then please include these 3 additional libraries. And then there's, of course, other steps to say -- with GD and so on and so forth. You can take a look at, for example, PHP's ebuild files there. They're quite readable. It's a shell script, so we know how to deal with these. Now, if you want to use Gentoo in Docker Linux, in Docker, then the Gentoo folks have actually provided some images. And there's 2 images here, and you can see that it's already a multi-stage build setup going on. The reason is that the portage tree being the repository of packages that you can install, the portage tree is hosted in a separate repository. The reason for that is that the portage tree is quite large. Now, we copy this whole thing together, and then we have a Gentoo base image. We could just start it, but there's a slight problem. If you look at the image and just look at the Gentoo image, what you will see here is this, 1.39 gigabytes. And you could think, okay, well, why do I care? It's a Docker image. It's going to get shipped. It lives on my server. I don't have to worry about it. And then I would like to, So this is basically Gentoo. Now, I would like to tell you a little bit of a story. I was down in Serbia on a company offsite, because some companies think that's a good idea, that you're more productive when you're not in your office. So I was on a company offsite, and we had kind of an emergency, so I needed to push a Docker image. And as it were, that Docker image push went over my roaming internet. So I had a phone bill of 300 euros. That was not so nice. Also, so that was not the only problem. The deployment took 20 minutes because it needed to go over bad internet and things like that. So having a large unwieldy image is not exactly what you would call agile. So this Gentoo thing seemed to be dead at this point. I actually gave it up for a couple of months and said, okay, well, this is not going to work. I guess the conclusion that we can draw here is that if you're going to build a Docker image, then you should have a quite small Docker image. You shouldn't put your debug utilities in there and things like that. At the end of the talk, I will show you how to debug your Docker container, even if your debug utilities are not in there. So that's advice number one, I guess, from me. However, I did not give up on this experiment, so I tried again. I just said, okay, we're going to try this. Gentoo has another nice feature. It can compile the source code of the packages that you're compiling into a different directory. So what we can do is we can create a destination directory and ask Gentoo, hey, can you please compile PHP with all its dependencies into that folder? So the idea was that I'm just going to take that folder that Gentoo compiled and take that as a Docker image. And that's what I ended up doing. So I create in my Docker file, I'm creating the destination, and then I'm just setting the root environment variable, which is telling Gentoo Linux that it should please compile into that folder. And then I'm just going to do emerge PHP. And then I'm going to wait a long time. Because what's going on here is Gentoo needs to compile everything from source, all the libraries, your operating system, everything. So you're sitting there about a good 20-25 minutes, and then you see this. Womp womp. It didn't work. It turns out that Gentoo Linux is great, but not all the packages are prepared to be compiled into a separate directory. Such is the case with PHP. If you compile PHP, it will not directly work in that directory because it has some dependencies. So what I ended up doing is compiling PHP in the builder system, so outside of the destination directory. So I have all the libraries and tools there, then setting the root, and then building it again into my destination directory. This is counterintuitive because why would you need PHP on the host system? But will save you actually quite a lot of times if you're trying to do this. The reason is that a lot of libraries, a lot of programs have dependencies that are not explicitly documented. So for build time, oftentimes they refer to files with absolute paths and things like that. And that will actually not work if you're building into a destination directory. I wish this was not the case, but it's not realistic. So to take home, if you're going to build something from source, then software can have hidden dependencies. So you will find that during the compilation step, it will link to undocumented libraries if you have them in your system. And sometimes they will even, if the library is there in your system, it will build in the dependency into your project, even though you didn't specify that you wanted to link to that library. Okay, the other thing that you will find out is that a lot of software depends on packages runtime. For example, in PHP, if you want proper time handling, you need the time zone data. The time zone data in Linux contains the information which country was in which time zone at what time, because, for example, a couple of years ago, I guess Samoa switched from one side of the date separator to the other side, so they just changed time zone because they wanted to be closer to Australia because they're doing more trade with them. And such is the case. Every couple of years, a country decides, okay, I want to be in a different time zone. And then if you need to do calculations with time, then you need this time zone information. So in order to do these time calculations in PHP, you need time zone data. If you don't have time zone data, bad things are going to happen, and you will not notice until you run it in production. At this point, well, my PHP image is still 1.48 gigabytes large, so no improvement there. No surprise, since I just compiled PHP, I didn't do anything. But there we go, weight loss is coming. How do we slim down this image? We are going to use multi-stage builds. The first stage of the build compiled the whole Gentoo system, so unpacked the whole portage tree, the full Gentoo system, as if you were to install a computer. However, what we're doing here is we're going to start from scratch. And if you start from scratch, then you will have an empty Docker image. And then we're going to use the copy operation and say, from the previous steps, please copy the destination folder into this directory. And what this is going to do is take the compiled details, so the compiled application without the whole Gentoo build system and portage tree and whatever, and put that into a new Docker image. And there we go, 112 megabytes. That's reasonable. It's not perfect, but it's close. So that leads me to the conclusion that you should take home that multi-stage builds are great if you want to squash the previous layers. We have learned over time that if we install something, for example on an Ubuntu Linux, then we should put that into one run command, because the one run command is going to create one layer. However, with multi-stage builds, we can do this. We can do multiple run commands and then use multi-stage to compress those layers together. So this is actually going to yield a single layer. The drawback, of course, is that you cannot rerun the individual steps independently all the time. So it's, for all intents and purposes, it's going to be one layer. But you can use this, for example, if you compile a piece of software, you need a bunch of installation tools and whatnot, and then squash the whole thing together. Just take the results and put it into a Docker image. Again, this is up to how you want to do things. This is not necessarily the way you should always do this, but if you have a particularly large build script on the top of your Docker file, you can use this to squash the whole thing into one layer. The other thing that I noticed is that Gentoo Linux does install a couple of utilities that I, for all intents and purposes, did not need. For example, I did not need the file binary, I did not need the sed binary, but it's a dependency of core utils, so Gentoo Linux just pulled it in as a base. So I ended up cleaning that up, removing those packages, and Gentoo Linux had a very stern warning about, hey, you're going to break the system, don't do this, yada yada. I just happily ignored it and made it such that these packages are no longer in there. This is also true for other operating systems again, depending on the flavor. Operating systems often contain packages that they think will be useful to their users. For example, most Docker images, if you go for an Ubuntu base image or even an Alpine Linux, will contain some sort of a shell. That shell will have utilities with it, and depending on the flavor of the operating system that you're installing, this is going to take up space. So if you want to go for a really small image, then you need to kind of look at it. Okay, do I really need those packages? Can I somehow get rid of them? Similarly, there is a bunch of files in the target build that I don't need. For example, if you look at this one, there's USR share docs. I don't need docs in my Docker image. I don't need USR share info or man pages or anything like that, because documentation, it's nice, but in a Docker image, it's kind of pointless because nobody's going to use man in the Docker image, at least hopefully. So apart from containing unnecessary packages, even the necessary packages often contain stuff that you don't need and that you might want to clean out of your operating system if you're going to go for a small image. Again, if you look at it, if it's above 100 megabytes, then you probably want to take a look at your what is exactly taking up the space in your Docker image. And with this, I came down to about 72 megabytes for a PHP image. That's quite respectable. It's about the size of the Alpine Linux PHP image, I believe. You don't really get any smaller. But the source code is a little bit terrible. So I promised you that I will explain how to debug minimalistic Docker images, how to deal with the fact that we don't have any debug utilities, we don't have ifconfig, we don't have netstat, we don't have strace, we don't even have a shell oftentimes. And this can be done if you're looking at basic Docker using namespace sharing. I had a previous talk about how Docker works and how namespaces work in the Linux kernel, and what is happening that, for example, for the network namespace, if you're starting a Docker container, then Docker is creating an own network stack, to simplify it roughly. So you're basically having a separate network interface in your Docker container that has a separate IP address, and that is connected on the host operating system to a virtual interface. So that means that any application running in the Docker container cannot, for example, send packages from the host operating system's IP address. It can only use its own network stack. And again, I'm simplifying here. What we can do is ask Docker to please run a container that runs in the same network namespace as our production environment. So simply denoted here by target. So we can actually run a fat container that contains all our debugging tools in the same namespaces as our other Docker container, which, for example, only runs PHP and has no shell. We can do the same with the PID namespace. So, for example, we kill processes or send signals to processes that are running in that other Docker container. For debugging, we can also add capabilities. For example, if we want to strace a command, we can issue the sysptrace capability to that container. And that's going to help a lot with debugging this container. I guess the conclusion is pretty simple. If you're going to go for minimalistic containers, which I recommend, then you can use separate containers to fix issues. Now, how do you apply this to your everyday workflow? Because let's be quite honest, you're not going to go and run Gentoo on your production servers because nobody supports it. There is very few people who actually deal with Gentoo on a daily basis. So as nice as it is to have customized images and customized software, you're not going to do it. This is an example, of course, with meta code, how you could do it. You could, for example, start with an Ubuntu base image, install all the build dependencies. If you're doing Java, then you could install the Java development kit, install libraries, and so on and so forth. And you could then build your software. Copy in, of course, the source code, and then build the software. If you're building something like Nginx with Lua libraries, then you could use wget to download it. But you're not going to use wget in your production environment, so you're going to leave it in the first stage. Now you're building all your software, for example, into jar files if you're working with Java. So as a second step, you're going to take Alpine Linux, which is, for example, a really small Docker image as a base image, and then you're going to copy over your build artifacts. So you're going to take the compiled binaries or the jar files or whatever you built, and you're going to copy that over into this stage. With that, you get rid of all the layer history of the compilation steps. And finally, then you're going to point to your application, please run that. And the result, what this is going to have is that you still have all your build tools. You can install build utils, you can install curl, wget, whatever you need, and not have a problem with having a fat image after the fact. And you can extend and customize this as you want. And this is actually something that I would recommend rather than running Gentoo. What if you're crazy? What if you're saying, okay, let's run Gentoo in production, because why not? In that case, somebody pointed me at the Kuebler project run by one Eric Dannenberg, who I have also been in contact with. And this is how it works. First of all, there is the GitHub link. Feel free to check it out. I recommend it. It's a really well put together project. And then in honor of the fact that somebody's already talking about it, he actually put out a new version just today, which is supposed to simplify and clear up a lot of things. So if you want to run Gentoo in a Docker container, I strongly recommend that you check out his project. And now let's take a look what's happening. The first line is actually how you create a namespace in Kuebler. You tell Kuebler to, hey, just make me a namespace. And what a namespace is a collection of Docker containers that you maintain together. And the fun fact is you can ask Kuebler to please recompile a whole namespace. So let's say you have a project, that project needs 5 Docker containers. Then with Kuebler, you can ask it to, hey, please recompile me the whole project from source, install all the newest libraries and whatnot. And then it's going to ask you a couple of questions. Who is the maintainer? What's the email address? So on and so forth. And then it's going to give you, okay, here's the source code, there's the path. Go for it. What you can then do is say, okay, Kuebler, make me a new image. In this case, my nickname / PHP. And then it's going to ask, okay, what's the parent image, and so on and so forth. You can customize this later, so you can just enter through the whole thing. And that's going to create another directory. And in this directory, you have a couple of files. First of all, you have build.conf. In build.conf, you can tell Docker, or more precisely the builder, how to behave. This is something that Docker by default does not support. So for example, you can add capabilities for the build process and so on and so forth. So if you need to compile, for example, libc, because I don't know, then you can use it to add capsys ptrace. Because in Docker, normally, with normal permissions, you cannot compile libc. So if you have libc compilation in your Docker file, that's going to fail. But with Kuebler, you can actually do that. And then you can use the parent image to say, okay, I want to go from scratch, or I want to use something else. That's all up to you. Then you have build.sh. Build.sh is very similar to the Gentoo philosophy, where you have a script that you can hook into. In this case, you remember I said that in order to compile PHP, I needed to compile PHP in the parent system as well. So that's what configure Bob does. I'm not entirely sure what Bob stands for, but I'll take Eric's word for it. And then you say, okay, please compile me devlang PHP with these use flags. And then you have the second step, configure root fs build, is where I say, okay, update the use flags for these packages. So please compile these packages with those use flags. And then that's actually it. So that's all you need to do. My own messy Docker file to do this whole process was about 50 lines long, and it was really ugly to look at. This is pretty neat and simple. And then you have the dockerfile.template. And this template is going to get a couple of variables. And you see that it basically consists of, okay, take the rootfs that has been built, put it into that directory, and then you can customize it with additional steps like what CMD to run and so on and so forth. So what's happening here is that Kuebler is building in a separate Docker container, then taking the destination, putting it in a tar file, and then you can have a nice and clean Docker file where you can put your stuff in. And this is the result, 65 megabytes. I don't know how he did it, because he didn't do any PHP-specific cleanup, but I guess he has some pretty good routines for Kuebler to clean up the image as it is, which is pretty cool. So this actually is somewhere in the ballpark of the official PHP images that are on Docker Hub. So you can actually have a customized PHP image that where the build instructions consist of less than 20 lines of code and is also of a reasonable size. So to recap, these are the things to take home. First of all, I really recommend that you build minimalistic images. If you have big images, they take up a lot of space, the push takes long, the build takes long, your deployment process is just going to suffer if you have to push a 1 GB image from your CI system into your registry and then to your worker nodes. Whatever you say, even if you push multiple layers in parallel, I've never seen a build process finish under 5 minutes if you have gigs of images. Maybe you have, but in general, this is not working all that well. The second thing is that you can have hidden dependencies in your software. So it's not like a one-size-fits-all recipe to compile source code. You always need to take a look at, okay, what's going on? What is that software doing? Is it working correctly? Which also highlights that you should have integration tests for your Docker images. You shouldn't just simply build a Docker image and then YOLO ship it to production. You should have actually tests that make sure that your Docker image is working correctly. In my previous project where I was running Nginx with some Lua code compiled in, we actually had a full end-to-end test which pulled up a database server that Lua code needed, a PHP backend, and then fired off requests and checked the responses if everything was working correctly in a proper integration test manner. This is very important. If you don't do this, then you're basically playing Russian roulette with your Docker containers. You can use multi-stage builds. This is a feature that I found out during this project. Multi-stage builds get rid of the extra layers as it is documented, but not many people know of it. Then, of course, the necessary cleanup. OS packages or operating systems are built with the expectation to run a full operating system and not run a container. So many Linux images, many Linux packages will contain extra stuff that you don't need in your Docker container and that you can get rid of. And finally, if you're going to debug something, don't put your debug tools into your production container. That's what your extra debug container is for. And that's the end of my talk. If you have any questions, I would be more than happy to answer.